go for another attack, that is STP attack. Now, all those who know about STP, like spanning tree protocol, you must be aware that spanning tree protocol is basically used for mitigating layer 2 switching loops, right? Layer 2 switching loops. Earlier, they noticed that if you have redundant links between switches, it is going to form layer 2 loops. And in order to avoid this layer 2 switching loops, they came out with spanning tree protocol. Now, when they came out with spanning tree protocol is having its own way of handling this layer 2 switching loops. And what is that way? Spanning tree will take 50 seconds, that is the STP convergence time. Spanning tree protocol, which is IEEE 802.1d, it's going to take 50 seconds to do STP convergence. Now, what is STP convergence? Spanning tree is going to form a loop-free environment on a switch network where you have redundancy among switches. So what is the like basic overview of spanning tree? That he is going to form a root bridge, which is a focal point. He is going to form other switches as a non-root bridge, or he might have a primary root bridge and a secondary root bridge also, because Cisco afterwards came out with a new feature called per VLAN spanning tree plus. Now, per VLAN spanning tree plus was Cisco's proprietary feature of STP, where he gave the funda that you can have multiple root bridges also. For every VLAN, you can have a root bridge. So we're talking about a primary root bridge for a particular VLAN. We are talking about a secondary root bridge for a particular VLAN. So if you're considering all those things, root bridge becomes very important and integral part, because root bridge is like a captain. Root bridge is like a focal point. Okay, so it becomes necessary that you should have a root bridge, and you don't have to configure a root bridge. It's already configured. As soon as you run STP, which is already there inside the switches, you don't have to run any command also to do STP. So once STP is running, working fine, it's going to form a root bridge. Now, once the root bridge is built, root bridge is like a focal point who has to be there in the switch environment, because that is the only switch from where the BPDs are going to flow. That is called bridge protocol data units. Switching information. There are a lot of stuff inside that BPD. You'll be having some hello timers, you'll be having some max age timer, you'll be having some kind of other details also, like priority, which is also called as bridge ID. So all those information are clubbed inside a packet which is called bridge protocol data unit and being forwarded on the root ports. So remember the term root bridge is very important. Then you have root ports. Root ports are there on the non-root bridges. Okay, so if I show you the diagram, now in this scenario, you see this, the top one is a root bridge. Just taking an example where you have these switches and there is a redundant links. So this fellow is a root bridge on the basis of bridge ID. What is bridge ID made up of? Bridge ID is made up of priority value and the MAC address. So the MAC address is 1000. Lower the bridge ID, preferred is the switch. Now, just because this fellow is a root bridge, what is the role of the other switch? They are non-root bridge, definitely. You cannot have You can have multiple root bridges, but at present for all the VLANs we have only one root bridge in this scenario. Okay, if you are very much aware of all those, okay, you tell me. If you are still getting confused about this spanning tree protocol, then you tell me. Okay, you can stop me and you can ask me. Okay, so I'm just giving an overview like how this spanning tree elects a root bridge on the basis of bridge ID. Bridge ID is comprised of priority and MAC addresses. Other switches are to be considered as non-root bridges, like for example switch 2 and switch 3 is a non-root bridge. One more switch is also there, fourth switch and fifth switch. They are all considered as non-root bridge. Okay. Now the question is, I want this topology to remain as it is till the end. I don't want anyone to disturb this topology, because as a network administrator, I have seen, or I made it 100% assured that this topology is a smooth working topology where you have a very good root bridge working fine. This is a distribution layer switch, switch 1. I know that the distribution layer switch be elected as a root bridge. I know that switch 2, switch 3 belongs to access layer and they are non-root bridges. Everything is working fine and I don't want anyone to disturb this topology, right? Like if you are a gardener, somebody is a gardener, he wants his garden to be look very beautiful. So what he do, he sow some seeds and then he put some plants and then the garden bloom, like it's beautiful, all flowers, trees, small plants. So early morning when I go for jogging, I see kids are playing cricket. Now when the cricket ball comes near that plants, they always come with their bats and they always try to find out the ball inside that greenery, like grass or the plants. So I have seen these kids, not only kids, the elder ones also, like young boys, they take their bat and they try to hit the plants to find out the ball. In fact, in the morning only I shouted one guy, why you're spoiling the plants when it is already looking so beautiful, and it's the hard work of that gardener, and just to find out a ball you are just trying to kill them with the bat. You should think like that, before doing all those things, that that fellow is working so hard day and night to make it look green and you're spoiling it just to find a ball. So why I'm giving you example, because whatever topology, whatever design I have decided, I have made it, I want this hard work to remain till end, because it is a I have thought about it. I know what is spanning tree, how it works, what are the fundamentals of. I want this to remain. And for that full proofing, what I did, I am going to use some kind of guards. So in the garden also there is a guard, but in that morning the guard went to drink tea or something like that. So when he come back, he started scolding these boys. In fact, he ran with his stick to hit them, because he also must have seen them doing all those things. So he was behind them to stop them to do that. That is the role of the guard, security guard of that garden. In fact, I shouted as a good citizen. Many other people also joined me and they started shouting, these boys, you people are doing wrong, you should understand. And after that, the security guard came and he started hitting them. He was about to hit them. They ran away. So try to understand, when the topology is converged, somebody is protecting this converged topology, and that somebody is called guards. So we have root guard. Why there is a root guard? So STP attacks again are something which want to spoil the whole scenario. They want to spoil the normal working of the switch network. So as a security administrator, as a security engineer, you also have to pay attention to these kind of STP attacks also, because if your STP is spoiled for some reason, then your whole switch topology will get disturbed because of that STP is misbehaving. So as a security administrator, as a network administrator, somebody has already built the STP convergence. As a security administrator or the network administrator can also have guards. And what is that? You have root guard for preventing anyone else to become a root bridge. You have Bpd guard so that nobody take or nobody misuse that Portfast. Okay, and then you have loop guard, and then you have UDLD. So there are many such features which are useful, and then you have Bpd filter also. So we are going to talk about, say, example Bpd guard. Now what is Bpd guard? So in your STP there is one feature called Portfast. Can anyone tell me what is Portfast? Anyone? Can anyone tell me what
Yeah,
is?
Portfast basically useful for to means that reduce the time convergence of STP,
Okay, it reduces
and
the time conversion of
Portfast
STP.
command hits on the at the agent host port,
Okay,
and it's come up with the BPD filter command, means
okay. So Mirza is also telling use for end devices, right, Mirza? And who is this? Tushar, I think, right?
yes.
So Tushar is also on the right track. Mirza is also on the right track. Yes, you guys are right that this Portfast feature is actually used for end devices, right? Spanning is discarded on this port. Mirza, I'm not able to understand this sentence. Spanning is discarded. What is the meaning of spanning is discarded on this port? Clarify it. You mean to say spanning tree is disabled on this port because you are using Portfast? Mirza, you mean to say spanning tree is disabled on these ports? No, no. Mirza, let me correct you. Spanning tree is not disabled on this port because see, disabling spanning tree on any port is risky. Mirza, please try to understand. Disabling spanning tree on any port is risky. By default, spanning tree is activated on all the ports and all the VLANs you create in future. Let me repeat. Spanning tree is by default enabled on all the switch ports and all the VLANs that you are going to create in future. Got it? So when you do Portfast, there are two reasons for doing Portfast. The first reason is as Tushar said, the convergence time. So I remember when I go to airport, any airport, international airport or local traveling airport, I always go for a security check. In fact, everybody knows that you have to go for a security check. If husband is there, you have to go for, husband has to go for a security, wife is there, wife has to. And remember one thing, each and every person has to go for a security check. That means when you connect any device to a switch, my switch is going to go for a spanning tree check, and that is called listening, learning, and forwarding. That means that port will be put to three states: listening and learning. The first state will be listening. He is going to spend 15 seconds, and then he will come to listening, learning state, listening, and then learning state. First is listening, listening. 15 second, after 15 second it will go into learning state, after 15 second it will go into forwarding. That means he is going to take a simple hold time of 30 seconds to bring that port up. Okay, now if you go to any airport, that shows that you have to go with a security check, that is for sure, and that is going to take some time. Now you are asking me how much time. I don't know. It is going to be much. If the queue is more, 1 minute, 1 minute. So if the queue is more, then you are going to take a lot of time. So now, how you are going to manage that time? You don't have choice. You have to sit. You have to stand in the queue. Okay. Here at least you are sure that after 30 seconds your port will be up. That is why they ask you to come fast. No, come 2 hours before or 3 hours before. Now everyone is being checked. Now a couple is standing there near the security check, and they have a newborn baby of say hardly 1 month old. Hardly 1 month old. Now what do you think? The security check will ask them to put that baby in the tray. You see, when you go for a security check, they ask you to keep your valuables like mobile phone, purse. In fact, some you have to remove your shoes also, and then they tell you to slide that tray inside that scanner. So think about a security check where you are asked to take your baby, put it in the tray, and then go for a scanner. You will kill that security guy. You will kill that security guy because he's asking you to do so. And you are going to be like irritated. What is going on, man? Why you want that small baby to be checked? My small baby is not a security threat, boss. And why you want to check that small baby? So same way, spanning tree, you're telling your spanning tree, boss, my PC is like a small baby. Don't do any, don't think of that he is going to create a loop. So I want this baby to be allowed without any problem. I don't want any security check for this baby. So when you enable Portfast, actually you're telling your switch or spanning tree that I don't want this end device to be checked. I want this end device to come up immediately without a hold time of 30 seconds. But that doesn't mean the security check has closed down the counter and telling everybody to go. No, the security check is still active. That means spanning tree is still active on the port where you configure Portfast. Only thing is he is not doing the checking of that particular device where you have configured Portfast. That is why it is strictly mentioned that do Portfast only on the access ports and not on the trunk ports. Access port is a port belongs to IP phone, PC, printer, or any end device. As you guys said, Mirza said, Tushar said, they are right. Now guys, spanning tree is still there, and that is the culprit. If spanning tree notices any BPDU coming on this port, if you have configured this port as a port fast, there is a chance that this port might go in the blocking state. Got it? Or there is a chance that there will be a switching loop. That means I told my spanning tree that, boss, I assure you, I'm going to connect an edge device to this port and there won't be any switching loop. I assure you. That means you have to follow that. But by mistake or purposely as an attack, if somebody connects a switch on this port where you have port fast configured, then there will be a loop. And remember one thing for your kind information, all of you, port fast is done for two reasons. The first reason I told you, to bypass the spanning tree timer of 30 seconds, that is listening to learning and learning to forwarding. First reason. Second reason, okay, there is a behavior of the switch that whenever there is a change, we call it topology change notification BPDU. Whenever there is a topology change, okay, so this kind of topology change where your PC goes down, PC is getting restarted or PC is shut down, this is a topology change for switch. Now switch will do what? Immediately send notice to all the connected switches that there is a topology change, there is a topology change, there is a topology change. Now what is this, man? If the PC is going 10 times down in the office time or getting restarted, the switch network is getting disturbed. Every time the PC goes down, switch is getting disturbed. Why? Because switch is telling, hey, all of you, my PC has gone down, man. Please note, remove the MAC address. Please note, remove the MAC address, remove the MAC address, please note. Then somebody comes up, oh, hello, please write down this MAC address. The person has come back. So what is this, man? You are disturbing the switch network every time. And this kind of topology change is called insignificant topology change. Insignificant. This topology change is disturbing the switch network. So in order to avoid the convergence time of 30 seconds and want the port to come up immediately, and in order to avoid the insignificant topology change, there is a tool called Portfast. There is a configuration called Portfast. When you configure Portfast, your port comes up immediately. So when you do this feature, what are you doing? You are saving your convergence time of 30 seconds, and you are also avoiding insignificant topology change notification BPDUs among these switches. Now anytime the PC goes down, they are not going to send any token. Yes, Mirza. Immediately, the word is immediately. That means if you connect a PC where Portfast is configured, it will not. You just see the practical, man. Wait. There I will show you how the root guard and how the BPD guard is also connected. See this PC is there. I'm not starting this PC. I'm just going here on the switch. Show spanning tree.
We get the access of this lab.
Hello. Hello. Yes, tell me, Tushar.
Hello. We get the access of this lab.
No, this is my laptop and EVNG. You can build your own setup. I can give you the files. I can give you EVNG. I can give you the images. Everything I can give you. You can have your own setup at home.
Your laptop, I believe.
Yeah, if your laptop is good with 8 GB RAM minimum, then you can build your own scenario at home and you can test it.
Okay, could you share me the configuration? What like?
Yes.
Not right.
I can share you the images. I can share you the EVNG. I can share. EVNG is easily available, man, on the website. Free.
Configuration is required. I don't know. I don't have any idea about the.
I will help you to install EVNG. No problem. I can give you router images. I can give you ASA license images. ASA license images. Okay. So you see E0 by 1 and E0 by 3. There are two pieces connected, right? E0 by 1. Can you see here? Just check it, Mirza and all others. E0 by 1 and E0 by 3. Now, I go here, check whether Portfast is configured or not. Because if Portfast is configured, then they'll come up immediately. See E0 by 1 and E0 by 3, nothing is configured. Let's see. Debug, spanning tree. events. Debug spanning tree events. Switch on this PC. Oh, heavy. Debug spanning tree. Show interface status. E0 by 1, NE0 by 3. Show spanning tree. E0 by 1 is designated and forwarding, E0 by 3 designated and forwarding. Okay, let's see. I just activate the second PC. I don't know. Debug spanning tree events. Show spanning tree. Do one thing. E0 by 1 shut. No shut. See now. E0 by 1 has come into listening. What time? 15:29. Still not up, huh? See, listening and then 15-second learning. Still not up. I just shut and no shut the port. That means it's same. 30-second. Can you see? 15-second, 15-second. That is 30-second forwarding. I go on this PC. Show IP 192.168 dot say 10 24. I go on this PC. IP 192.168 dot 11. See now. 10.10 and 10.11. Ping 192.168 pinging. Okay, 10.11 pinging. 192.168 pinging. Now I do what? Once again, shut and no shut. Shut. So when I shut, ping stops. Okay, ping stops. I do no shut. Ping will never come until unless it goes into forwarding. See. Listening. Ping still not up. That means this PC is struggling for coming up. You connected and you have to wait for 30 seconds. What is this? Your PC is never going to make any loop. Loops, actually loop is done by the switches, not by the PCs. Ping started, forwarding, ping started. Now we'll do what? Portfast. Check Mirza. Interface E0 by 1. Spanning tree. Portfast. Done. Warning is there. Don't do portfast on interfaces where ports where you have hub, concentrated switches, bridges, etc. connected. No shut. Sorry. Shut. Ping stop. Okay. No shut. No shut. Got it? Mirza? See what is the message you're getting? Jump to forwarding. Always see practically. You will come to know. Jump to forwarding because of portfast. Now see, this is not the thing we are doing actually, but just to make you aware what is portfast. The thing is, there was a warning given that portfast should be only enabled on port connected to a single host. And suppose purposely attacker connect a switch or hub or earlier we used to have VPN concentrators. Now we don't have hub, we don't have concentrated, but the message is still intact. We used to have bridges also. So now we don't have hub, we don't have concentrator, we don't have bridges. That means we have only switches. Switches are also called bridges. So when we connect a switch on this port, 100% there will be a loop. Because spanning tree is not at all disabled, my dear friends. Spanning tree is still active. But spanning tree was promised. You promised spanning tree, we are not going to connect. See, he also warned you. Please don't connect anything other than a host. And now you connect a switch purposely or by mistake. If you do, like you know, you are having a utensils where there is a very hot water. Okay, somebody in your family must have done hot water, and you go and touch that utensil. What will happen, man? Your hands will burn. Are you doing it purposely? No, by mistake. So what is the question arises here? Your family member should caution you that please don't touch that. Nowadays you have that facility inside that three pin point. There is a guard there. Have you seen that guard? Why there is a guard? Because in my days kids used to die because of that putting anything in that hole. That three pin hole is actually designed to put a point, like this is a point, charger point. Earlier people kids used to don't know about that. By mistake they put a nail here and they got shocked, electrocuted. So now they have what? A guard here. So here also we are going to place a guard. Which guard? Spanning tree Bpd guard. Enable. So when you place a spanning tree Bpd guard on the port, what will happen? If anybody by mistake also connects a switch or purposely also connect a switch, the port will go into error disable state and shut down. Check it. Check it. How? I WR this. Save this. I can save this configuration. Where I did this configuration? On both the interface. You should do it on both the interface. Or wherever you have configured Portfast. Wherever you have configured Portfast, there you do port Bpd guard. So I did it on E0 by 3 also, spanning tree Portfast. And then what command? So you see, show run interface E0 by 1 and E0 by 3. Both are access ports. How you know they are access port? You configured it. Switch port mode access. Switch port mode access. Access means access port. So 1 is access port, 3 is access port. WR it, save it. Now you go and stop this. Okay, no need to stop it. See, I am doing what? I am removing this and connecting a switch. Where I am connecting? E0 by 3. I start this. Let the switch starts. Okay. Debug. Spanning tree. Events. Show run. Your configuration is intact. 1 and 3. Okay. Okay. Show spanning tree. Let everything get converged. Yes, everything is converged. E0 by 1 is in forwarding and edge. Edge means end. Always the term edge is also there. Okay. Done. Now you see I activate this switch. Somebody by mistake connect a switch on a port where Portfast is configured. What happens? Somebody connects a switch on the port where Portfast is configured and Bpd Guard is also there. Now this switch starts and starts sending BPDUs on this port E0 by 3. The switch starts and starts sending BPDU. So as soon as this fellow receives the BPDU, see here, received BPDU on port number 03 and the BPDU guard is enabled on this port. So BPDU guard has put this port into error disable, BPDU error. See, you are safe now. Why you are safe? Somebody purposely try to connect a switch on a port which is already configured for Portfast, and because of BPDU guard you are saved. At least there is no switching loop. Somebody purposely wanted to create a STP attack, and who saved you? BPDU guard. Check it. You, how to bring this port up? You say shut and then you say no shut. Port is up. But again, again is doing problem. The other fellow is sending. Again it will go into error. Got it? So what you will do? We know what is the mistake. Take out the switch, throw away the switch. Don't connect here. Connect a PC. Start the PC. Start the PC. Start the switch. Enable. Show interface status. Gone. So STP attack. What is the STP attack? You have somebody is configuring Portfast. somebody everybody knows that all the access port are configured for Portfast. You have a global configuration command also. What is the command? Spanning tree Portfast default. What is the meaning of this? Wherever you configure access port, there Portfast is configured. Then you have one more command. Wherever you configure Portfast, there you configure Bpd Guard.
There's no matter.
So you have a global configuration command also for Portfast. You have a global configuration command for Bpd Guard also. Interface command also individually, but in lab and all they always ask for a single command, easy command. This command is best command. Why? Because it get enables on all the access port. Anytime in future you make any port access port, this will get enabled. Anytime in future you want to enable Bpd Guard, do the global configuration command. What is the meaning of this command? Wherever you enable Portfast, there you enable Bpd Guard also. And Bpd Guard is going to do what? Safe. When I am doing electricity, when I am doing wiring, electric wiring of my house, I see that there are trippers, safety trippers. So what is the role of that safety tripper? Anytime short circuit, immediately trip off and switch off all the power of my house. Safety. Afterwards I can start. Someone is asking some question. Wait. No, Siva Kumar. You can see show run. It's not allowed on the trunk ports. Okay. It is not meant for trunk port. Global configuration command is only meant for access port. In future, if you configure trunk, it will be still active. Okay. Like for example, these two are access port, no? So 1 by 2 is not an access port. Just see the diagram. 1 by 2. And you have a switch here. Got it? So I did global configuration command in front of you just now. I did a global configuration command and I did a Bpd Guard default also. Now, according to the diagram, E1 by 2 is connected to a switch. Just check. E1 by 2. And it is a trunk port. Can you see? Show run interface E1 by 2. Trunk port. Now if I start the switch, it should not go in error disable because it is not configured for Portfast. I started the switch on E1 by 2. It's a trunk port. I did a global configuration command. Still, it will be in the trunk mode only. Show interface trunk. Just check E1 by 2. It's still on. Show CDP neighbor. Can you see? Switch 5. Show interface status. Can you see? Still trunk, not gone into error disable. Clear? I did global configuration command. So your doubt was if I enable global with the enable global configuration, if I enable Portfast and Bpd with global, it will not get applied on the trunk port. Just now I showed you I connected one switch on E1 by 2. Still working fine. It's in trunk port. Never went into error disable. Okay. Good. So I hope all of you understood STP attack. What was that STP attack? Somebody was trying to harm the STP working. STP is a very important protocol working inside the switch network. It should work smoothly for your smooth moving of frames, data frames. Somebody disturbs the STP, your whole switch network will get disturbed. Just now you saw convergence took place. As soon as the port goes into error disable, everybody will get the notification. So it is a convergence, STP convergence. Next guard, next feature that we are going to discuss is the root guard. Everybody knows that this is a root bridge. Who made this root bridge? It can be automatic on the basis of priority, or you can make him as a root bridge. So I'll go on switch 1 and make him root bridge. How? I will change his priority. Config T, spanning tree, show VLAN. I have VLANs. Yes, I am having 10, 20, 30, 40. So suppose I want to make this switch as a root bridge for VLAN 10. So I'll say spanning tree VLAN 10 priority. Okay. If I don't remember the priority, I will say 5. Otherwise, it is in the multiples of 4096. So I say 5. Immediately I will come to know that what priority I have to select. So I selected 4096. When I say show spanning tree VLAN 10, you can see this fellow is a root bridge for VLAN 10. What is the priority? 4096 plus 10, 4106. The MAC address of the root bridge and the MAC address of this switch is same. That means this switch has become root bridge for VLAN 10 on the basis of lowest priority value. Now what happens if anyone comes with the best priority compared to this? Who is that fellow? Possible this switch or this switch. Okay. So I think this switch is the culprit now. This switch is a culprit. Let me start this switch. Go to this switch. Now this switch is a lower end switch, access layer switch. Host name switch 5. I say spanning tree VLAN 10 priority, I made it 0. So when I say show spanning tree VLAN 10, I can see now it won't show anything because there is no connection. There is no connection on the switch. Okay. So what I'll do, I will stop this switch and make a connection also. Stop. Stop. I will connect a connection between these two switches. Switch 3 E1 by 2. So here also E1 by 2. Now start this. Start this. So I go here, host name, switch 5, show spanning tree VLAN 10. I think I lost the configuration. Show spanning tree sorry, spanning tree priority, I make it 0. What will happen? Show spanning tree VLAN 10. You see, show interface status. What happened? E1 by 2. Show CDP neighbor. You can see E1 by 2 connected. Go here. Show spanning tree VLAN 10. Show CDP neighbor. Okay. Config T. Show interface trunk. See, in order to be member of this spanning tree, you should have all the configurations. So, what is the show VTP status? It should belongs to the domain name CCIE. Show VTP status. No domain name. So VTP mode server, it's okay. VTP domain is CCIE. Show VLAN. Any password? Show VTP status CCIE. Show VTP password Cisco. VTP password Cisco. VTP mode client. Show VTP status. VTP version. I am making him the member of this domain. So show VTP status. VTP version is 2. Okay, VTP mode server. VTP version is 2. Show VTP status. So VTP version is 2. VTP domain name is CCI server. Now check the VLAN. Not there. Show VTP status. Okay. Show VTP password. Okay. Show VLAN. There. Show interface trunk. Okay, trunking is there. Show VTP status. VTP version 2 CCI. Show VLAN. VLAN is there? Yes. Show interface trunk. Trunking is there. Show VTP status. Okay. Show interface trunk. E1 by 2 should be trunk. It's undesirable. So you go on interface E1 by 2 and say switchboard trunk encapsulation .1q switchboard mode trunk. No shut. Go to 5. Config T interface E1 by 2 switchboard trunk encapsulation .1q switchboard mode trunk. No shut. Show VTP status. Show VLAN. You can see all the VLANs have come. Always check the updated information. Show VTP status is a root bridge. What is the revision number? 5. Show VTP status. What is the revision number? 5. Show VTP status. What is the revision number? 5. Show VTP status. What is the revision number? 5. That means all are having the latest configuration revision number. So when you say show VLAN, there. When you say show spanning tree VLAN 10, you can see he has become a root bridge man. because of the lower priority. And who lost the election? This fellow got. See, he is also telling this guy is my root bridge. So there is a chance that this lower end switch has become a root bridge. Whole topology is disturbed in between. This guy was root bridge for VLAN 10. And now who became, why? What's the reason? This fellow was having a priority of 4096. And now this fellow has come with a priority of 0. Which one is the best? 0. So he became the root bridge. Whole topology is disturbed. Suddenly someone becomes the root bridge. What is this? And that also lower end switch. Access layer switch cannot become a root bridge. So you need to do some full proofing here. You need to see that you put a guard here. You need to put a guard here. You need to put a guard here. Because anytime anybody can introduce from this side. So if you think that this is an entry point for a new switch, anybody can enter from this entry point or this entry point, you put a guard. Which guard? Root guard. So let's do one thing now. We switch this switch off. Now who's going to become root bridge again? This guy. Show spanning tree VLAN 10. The convergence time is slow. Debug spanning tree events. I told you. Listening, learning, forwarding. Listening, learning, forwarding take place. There is a topology change. Received. So this guy is going to become now. He has become a root bridge now. Who? Switch 1 has become a root bridge once again. This guy has gone, culprit. Now we are going to put a root guard. Where you are going to put a root guard? On switch 3. What is the command? Interface E1 by 2. Spanning tree guard root. You can do it on all the ports. I'm just showing you that specifically I'm doing out E1 by 2 because you can do it on all the ports also. No, not a harm. Now you see root guard is enabled on port number 1 by 2. Now let's see if this guy comes with the best priority. Whether this guy is going to leave his position. No. Why? Because root guard is going to choke all the BPDs here only. All the superior BPD. He is telling my priority is 0, man. I can become root bridge for VLAN 10. This fellow is telling stop here only. Don't go anywhere. I am not going to send it to this switch. I am not going to send it to this switch. And if these two guys are not receiving, it's not going here also. So the BPDs are suppressed here because this port goes into root inconsistent state. What is the definition of root inconsistent? Don't allow BPDs to get forwarded to other switches. No BPDs will be sent to this guy. No updates, no BPDs, nothing is going to come. He is left over now. You want to see is left over or not? Come here. Show spanning tree. VLAN 10. Spanning tree VLAN 10. I think it was not saved. 0. See, he's telling I'm the root bridge. Okay, no problem. He's telling I'm the root bridge. When he says show CDP neighbor, is connected with switch 3 also. But switch 1 is still root bridge. Switch 1 is still root bridge. Switch 2 is still considering this guy as root bridge. Switch 2. Switch 2 is having root port E0 by 0. E0 by 0 is the root port. He's telling this guy is my root bridge man. What is the MAC address of this guy? Switch 1. 3000. Sorry, 1000. 1000 is my root bridge. See? 1000. 1000. Switch 1 is the root bridge for VLAN 10. He is telling yes, my boss is this guy only. Switch 3 is also telling that. Show spanning tree VLAN 10. He is telling yes, my boss is 1000. Switch 3 is also telling. See, switch 3 is also not following switch 5 as a root bridge. Let switch 5 tell whatever he wants. He is not connected to the domain only. He is out. He is not connected to domain at all. He can't even, he will not be able to ping these machines. He will not be able to go here. He will not be able to go here. He will not be able to go anywhere. He is blocked here only. How you know? Go on switch 3. And you can see there is a tag here, root inconsistent state. Root inconsistent means BPDUs are not given to this guy. Debug spanning tree BPDUs. E1 by 2 will not get any BPDUs. You all. E1 by 2. Just check the BPDU. I will show you. See here. I said debug spanning tree BPDU. See. You can see E0 by 1 transmit. 0 by 2 is getting transmitted with BPDU. 0 by 1 is transmitted with BPDU. Transmit. E1 by 2 is not getting BPDUs at all. Supersedes. Receiving is possible. You will not see the term transmit anywhere. No, this is like for VLAN 1. Huh? VLAN 10 you won't see. VLAN 10 you won't see. See here. Transmit is there. Transmit is there. 1 by 2 is not there. Huh? This is 0 by 2, 0 by 1. 0 by 1 there. For VLAN 10, E1 by 2 will not get anything. Because this port is in which state? Root inconsistent state. 0 by 2 transmit possible. E1 by 2. For VLAN 40 it's okay. Because you did spanning tree for VLAN 10. The danger of VLAN 10 is no more now. Because for VLAN 10, switch 1 is the root bridge, is still their root bridge. Switch 2, consider switch 1 only the root bridge for VLAN 10. Switch 3, consider switch 1 only for root bridge. Switch 3 is having inconsistent state. What is inconsistent? Don't allow any, see it is kind of a blocking. Understood all of you? Now switch 5 got the mistake. He said, sorry boss, I'm at mistake. I don't want to become accepted. Mistake is accepted. He changed his priority to 32,768 for VLAN 10. No problem. Check once again. Gone. Root inconsistent state is gone. Root guard unblock E1 by 2 on VLAN 10 because he accepted his mistake. He cannot become root bridge. Our root bridge is already there. We don't want any new switch to become a root bridge because I am a root guard. I'm going to block this port. If somebody comes with a superior priority, I'm going to put that port into root inconsistent state. What is the definition of error disable? BPDUs, sending of BPDUs and receiving of BPDUs and forwarding of data frames, everything is blocked. Nothing is working when the port is in error disable. What is the definition of root inconsistent state? Sending of BPDU is allowed on that port. That means this fellow can send BPDU on this port, but he will not receive any BPDUs. He will not receive any data frames. He cannot learn any new MAC addresses. Then why they kept it like that? That this can, because this switch want to know what is his priority. If he's telling 0, get lost. If he's telling no, I am 32,768, no fear, because this guy is 4096, no fear. Allow him. Allow him. Allow him. Now he is not a risk. If your temperature is showing high and if your COVID report says you are having a COVID, nobody will allow you. If you show a report that yes, I am clean now, allow. Who will do that? Guard. Guard will check. I hope all of you understood these spanning tree attacks. I showed you with practical. I applied BPD guard and showed you. I applied root guard and showed you. What is error disabled? I explained you. What is root inconsistent state? I explained you. What is the requirement? Why there is a requirement of root guard? Because you don't want any new switch to come with as a root bridge for VLAN 10 and disturb the whole topology, spanning tree topology. Someone is asking question. Sivakumar, see, basically when you are asking me a question, it's a good question. See, attacker will try to disturb the other network. See, if you think, see, attacker is not having control on your existing switch. That means switch 2 and switch 3 has no, he is not having control. What he will do now, attacker, he is a smart guy. He will bring a new switch with priority 0 and try to disturb your whole network. Who? Attacker. So as a Sivakumar is the administrator for these switches. Sivakumar is the administrator for this. Sivakumar don't know about this switch. This is attacker switch.
One question, like it's the root bridge selection is already finished in the network. It's so
Right.
the one of the switch became a root bridge.
Right.
So in that network, the attacker is connecting a new switch and try to reduce the priority and try to become a root bridge.
Correct.
So in that scenario, the switch will
Stop.
activate this root guard, right?
Yeah. Right.
Okay.
You have to configure manually.
Yeah, manually.
On
Okay.
switch 3. So switch 5 belongs to the attacker, no? He purposely
Okay.
come with a switch whose priority he reduced to 0 and he connects it. And what will happen? Immediately that switch will become a root bridge and the whole traffic flow will change their mode. Like, suddenly, like you know, there are fires in the camps. There is an exhibition. So people don't die with fire. People die with stampede.
Okay.
Somebody asked why, how come people are not dying with the fire in the camp and why people are dying with the stampede? When there is a fire, people rush to the exit, right?
Okay.
And when they rush to the exit, they find out that there is a fire there, so they turn back. And when they turn back, the people which are rushing toward exit and the people which are turning back, they clash and then they die. So
okay. In this scenario, for example, the attacker is not connecting the switch, okay? And the switch 2, switch 1, switch 3. In this topology, for example, switch 1 is the root bridge, and the root guard is enabled on all the ports, And
Okay.
if I want to make the switch 3 priority, or if switch 3 to become a root bridge,
So
this
switch,
possible, right? Switch 3. For example, the
no,
switch 3, I
not
want to
possible.
make this.
Switch 2 is already you said switch 2 is already configured for root guard, no? So switch 2 will stop switch 3.
Switch 2 and switch.
Yes, switch 1
Okay.
and switch 2 will stop him not to become root guard, root bridge, because
Okay.
you yourself or somebody else must have configured that, no? So that will not allow you. So if you really want to make, you are a good administrator and you really want to make switch 3, then you remove the root guard from 1 and 2 and then you connect.
Okay.
Then you connect,
Okay.
because you
Okay.
are the genuine administrator, na? See,
Okay.
administrator is having a login to all these 3 switches, na?
Okay.
Switch
So we need to
5.
disable that root guard from the switch,
Yes, yes,
right?
yes, yes.
Okay.
Otherwise, he is going to put that port into root inconsistent.
Okay, got it. Got it. Okay.
So I hope you understood the STP attacks and one minute. Huh? So what are the different STP attacks? We studied that we have BPD guard, then we have root guard. Okay, these were the STP actually attacks that can be done on the switches, and these are the guards which can be implemented to mitigate these attacks. I hope you understood this. An end user workstation is usually connected to a switchboard. This is the definition. This is, where is that gone? Guard. This is the command. So whatever practical we did today, I will send you the topology and the commands. Okay. Portfast, BPD guard, root guard. One more is BPD filter. Now what is BPD filter? BPD filter means, like, you see, whenever you receive a BPD from root bridge, this is a general rule in spanning tree, that only root bridge is going to send BPDs on root port. So this is root port. Root port. Now this can be designated port or block port of both the switches. So let's see which one is designated and which one is root port. So we go to switch 2 and say show spanning tree VLAN 10.
Yeah, what is this type SHR?
Shared. Hello. Many
Yeah, I
times,
don't get it.
see, basically when you connect two switch, okay, and if that switch is connected with multiple switch, or if the port is in half duplex, okay, then it is shared. This is, you can see, it is Ethernet. Okay, so port types are either point to point or shared. Okay, so this is showing it is a shared. It's,
Okay, okay, got it, got
yeah.
it.
Yeah. So now I was telling you that switch 2, okay, is having a root port towards root bridge, because he knows that this is your root bridge, switch 1. 1000 is the MAC address of switch 1. Huh? When you go to switch 3 and say show spanning tree VLAN 10, we are just looking spanning tree for VLAN 10. You can see this guy is also telling that I am having E0 by 1 as the root port. So this is root port. This is also root port. Now let's see which port has become blocked, because loop has to be avoided. So when you go here and you see E0 by 2 has gone into blocking state. So this is your designated root port. This is your root bridge. All the BPDUs are coming on the root port. Huh? From here also it gets forwarded. Now think of a scenario where this switch is receiving BPDU from this guy and he's forwarding on all the designated port. Or think of this fellow who's having a scenario where he's receiving and he's forwarding on all the designated. Here also. This fellow also sending here, except on this port because this is blocked. So he's not saying. So what switches are doing basically, when they receive a BPDU, they're taking for themselves and forwarding on all the ports. Forwarding on all the designated ports. That means you see, when I talk about switch 2, he is having multiple designated ports. He is having this PC also connected here. Got it? So he is having these ports also, okay, designated. Okay. So now what he will do? Whenever switch 2 receives, he is going to forward it on all the designated port. Like for example, if I activate this, E1 by 0 also become designated. E1 by 1 is also designated. E0 by 3 is also designated. Huh? These two ports are also designated. Show VLAN. So show spanning tree, VLAN 10. Show run. So E0 by 1, E0 by 3, show spanning tree. E0 by 1, E0 by 3, interface range, E0 by 1, E0 by 3, switch port, access VLAN 10. Suppose they are member of 10. So when I say show spanning tree VLAN 10, you can see all these ports are designated. So how many ports are designated? E0 by 1, E0 by 3, E1. Designated means what? Everything is running smoothly. All the forwarding is taking place. Nothing is there. But now what happens? If you say debug spanning tree events or debug spanning tree BPDU, you can see that the BPDUs are getting forwarded on all the ports. All the ports. Let's check it. All the ports. Huh? BPDUs are getting forwarded on all the ports. See, root port they are receiving and they are forwarding on E0 by 1, E0 by 3, 1 by 0, 1 by 1 and 1 by 2. See, receiving on E0 by 0, forwarding on 1 by 0, 1 by 1, 1 by 2, 1 by 3, 2 by 0, 2 by 1, 2 by 2, 2 by 3. What is this? You only think and tell me this switch is connected to another switch on this port, another switch on this port, another switch on this port. So if he is forwarding here, it's okay. If he is forwarding here, it's okay. If he is forwarding here and here, it's okay. Why? Because these guys understand BPDU. This guy understand BPDU. This guy understand BPDU. But what about this guy? They understand BPDU? No, BPDU is a bridge protocol data units which is understood by only switches and not by PCs. So why they are wasting time in sending BPDUs to these guys? E0 by 3 and E0 by 1, they are wasting time. Who's going to listen? It is like passive interface in EIGRP and OSPF. Unnecessary sending the BPDUs on those ports which are not understanding BPDU. So you need to do what? BPDU filter. Spanning tree, BPDU filter, sorry. You have to go on that specific port. Interface range E0 by 1 and E0 by 3. And then you say spanning tree, BPDU filter, enable. Now you see E1 by 1, E0 by 1 and E0 by 3. Already E0 by 1 and E0 3 was considered in sending the BPDUs. This is not good. PCs don't understand BPDUs. Why the switch is wasting his time and resources sending them BPDUs? What they will understand? Let's see after doing this. So now you will see, you won't see E1 by 2 and sorry E0 by 3 and E0 by 1. Pay attention on E0 by 3 and E0 by 1. You will never see those ports. Just check the output. See, I did this here. That means BPDU filter is going to see that these BPDUs are not sent on those ports which are configured for Portfast. E0 by 3 and E0 by 1. You won't see that. E0 by 3 and E0 by 1. Just check. E0 by 2 is there. E0 by 2 is there. If you see the earlier output, E0 by was there. I showed you that time. But in this output, you won't see them. So what is the role of BPDU filter? BPDU filter is going to disable. Now here the term is disable spanning tree on these two ports. Because the switch is very much sure, or you are also very much sure that you are going to, you don't have this any spanning tree activity to be done on these ports. So you go for BPDU filter, because BPDU filter is going to stop all the BPDUs being sent on these ports, because nobody is there to listen the BPDU. So BPDU filter is a guard, or is a configuration, or is a feature which helps this switch to filter the BPDUs on these ports. It's like passive interface. When you configure passive interface on fast Ethernet or gigabit Ethernet, switch will never send it hello packets on those. It will be filtered. Switch will send the multicast hellos on these links. Why? Because they are running OSPF or they are running EIGRP. So passive interface is something which filters the hello packets. Got it, all of you? Any question? Okay, good. So we have done Portfast, BPD guard, root guard, BPD filter, and I showed you the practical also. The next topic is port security. Again, it's a small topic. Now everybody, they must have done also port security. They must have configured in the field also, and many also must not be knowing what is port security, or if you are knowing also, please listen to this lecture. It is short lecture. Port security. Why people go for port security? Anyone? To mitigate which kind of attack? Why people go for port security? To mitigate which kind of attack? Anyone? Arjun, Mirza, anyone? No one? Okay. So port security is actually done to avoid an attack, and that attack is called MAC flood attack or CAM table overflow attack. Now what is MAC flood attack or CAM table overflow attack? An attack where the attacker is trying to send fake MAC entries to the switches. This happened in the beginning when Cisco started manufacturing switches, when he took it from someone else and started manufacturing switches like Catalyst switches. He took it from Kalpana Networks long back. Cisco was not into manufacturing of switches. Cisco took it from Kalpana Networks, a US based company. It sound Indian name. It's already NRI or something. So they kept that name Catalyst switches because it was Cat OS that time running. That time the maximum capacity of a switch MAC address was only 14,000 for certain models. Now also for certain models the capacities might be 14 to 15,000 or more also, whatever. Now my hacker knows or my attacker knows that if I send 14,000 and more, what will happen? The whole table will be full with MAC addresses. But which MAC addresses? There will be hardly some authorized MAC addresses, and all the other MAC addresses will be fake MAC addresses. How is going to do that? There are tools available. Dsniff MACoff tool is going to send lot of fake MAC IDs to the switch. So switch will have what? The whole table is full with fake MAC address. So what will happen? Again, there will be one more attack. What is that? Just because the MAC table is full, the switch is not able to store authorized MAC addresses. So anytime there is a request coming for the authorized machine, he is going to do broadcast. See, switch is having three functions to do: address learning, forwarding, filtering decision, and loop avoidance. So address learning process is stopped because his table is full. So if it is table is full, how is going to learn and keep those MAC addresses, authorized MAC addresses in the MAC table when you don't have space? Because attacker knows that 14,000, 15,000 MAC address, so he'll send 20,000 MAC address. 15 is full, all the 5,000 will be dropped, and the switch is misbehaving now. Switch is always doing what? Broadcast. He is behaving like an herb man. Anytime the request come for a machine, MAC address is not there in the MAC table, he is going to do broadcast. Every time. So attacker wanted this thing to happen. He wanted to misuse this facility. He knows that the switches have a capacity to store MAC addresses in their MAC table. I remember Foundry switches, 1 lakh. They started a model with 1 lakh capacity. 1 lakh MAC address can be stored in the Foundry switches, not Cisco, Foundry. Motorola company was having those switches because Motorola company wanted mobile connectors or mobile users to have their MAC address stored on the switches for longer time. They wanted the more MAC storing capacity, so they bought Foundry switches. Cisco switches was having less capacity. Attacker knows about that. He flood the MAC addresses. Secondly, there is no guarantee if someone comes in your company and connects to the switch. How you will come to know if somebody comes and connects his laptop to the switch? Wired connection, I mean to say, not Wi-Fi connection. Who's going to keep tab? Who's going to keep watch on them that they are connecting? Unauthorized users. I don't want unauthorized users to get connected to the company switches, and for that reason I'm going to use one technique or one tool called port security, because I don't want unauthorized access to come in. I don't want an attacker to flood or do MAC flood attack, and because of MAC flood attack or because of your switch can crash also. Possible. Misbehave, continuously doing broadcast. So for those reasons they came out with what? Port security. When you do port security, exactly what happens? It can store only by default one MAC address. What is the command? See here. All the access port I activate port security. What is the command? Switch port mode access, because I do port security on access port. Why? Because I have users connecting to access layer switches. Switch port security is the first command to activate or enable port security on the switches. If I don't give this command, which is an optional command, what will happen? He will allow only one MAC address. Only one MAC address will be allowed. So I don't want one. I don't want one. I want more. Like for example, I have 3 shifts. Or suppose I am having an IP phone connected to this port and then a PC. So definitely there will be 2 MAC address coming on this port. So instead of 5, I can say 2. You have a limit, 1000 or 2000 MAC addresses allowed per port. It's okay now. 14,000 is the capacity, man. And you have a 24 port switch. If you allow 10 MAC address also in each port, the table is not full. But at least that attack is mitigated. Which attack? MAC flood attack, where the hacker is trying to send multiple fake MAC addresses and full the table. Now he won't be able to do, because I implemented port security. By default, only one MAC address will be allowed if I don't give this command. But here in my scenario, I have 2 people. Yes, but see, authentication part can be done. See, ICE is going to take care of the authentication part. Port security is actually not allowing physical machines to get connected. Simple methodology to secure the port, access port. Okay. So authentication part is a separate thing. Authentication, like user can connect to this switch and get authenticated. You can use .1x for that. You was asking me for .1x. Yes. So you can have that also, .1x, because see, port security is only doing filtering on the basis of MAC address. Remember, port security is doing filtering only on the MAC addresses. But if you are talking about ICE, if you are talking about .1x authentication, then actually the user is getting authenticated with username and password. That is more powerful than port security. So you only think, if you want to go for port security, or you want to go for .1x authentication, that is with ICE. ICE is just a server which is going to help for authentication, authorization and accounting. Earlier we used to have ACS. Got it? So port security is not that strong, because what is the drawback of port security? He is doing filtering on the basis of MAC address and not on the basis of user. Got it? Because anybody can spoof the MAC address. No, I can keep my somebody else's MAC address and I can enter, because he is allowing me on the basis of MAC address. MAC address can be easily spoofed. There are tools available to even spoof MAC address. But still, the feature is there in the topic. So switchboard port security, and I can statically put this again. This is optional, because here I am statically adding this MAC address. Who's going to add MAC addresses, two MAC address on each port? So this command is also not possible. So you go for what? Sticky. Now what is the meaning of sticky? Anybody connects with this machine, the MAC address will get stick to the port, and it will be permanent when you say WR. What will happen? If you connect a machine to a port, that MAC address will be learned dynamically by the switch on that particular port, say port 1, and he will immediately stick that MAC address to that port, and you can WR it, you can save it and keep it permanently. If you really don't want it permanently, you can make an aging type also. Like if there is an inactivity, you remove that MAC address, but you want it permanent. So don't give this command, optional command. What is your aging time? If you want that MAC address to get aged out after 5 minutes, you can do it. Always remember 300 second is the default aging time of MAC addresses on a switch. Whenever switch learns a MAC address dynamically, and if there is an inactivity, it will immediately remove after 300 second. That is 5 minutes. You can increase that time, MAC aging time. So you want this port should also remove that MAC address, then you can set. Otherwise, just keep it sticky and save it. What happens when somebody connects and he is not the, so what is the default violation? Shutdown. What is the second violation? Restrict. And what is the third violation? Protect. So what happens when somebody connects and he is not the authorized MAC address sticked on this port? The port will immediately go into shutdown, that is error disable. What is the meaning of restrict? Shutdown is the correct solution, default solution, but you don't want, because again that can also be an attack. I remember in my company long back, somebody came with the unauthorized MAC address and started connecting to the ports. Table 1, there were 5 ports, so he connected on one port. That port went into error disable. Second port, error disable. Third port, error. Fourth port, error. So whichever machine was connected on that table, they also lost the connectivity. Because when the port goes into error disable, manually it has to be done shut no shut, or dynamically also you can do with the command MAC address aging, error disable recovery cost and error disable recovery interval. First you have to mention the cause. So you said P secure, that is port security. And then you have to say error disable recovery interval. 30 seconds is minimum. So if you have not done this command, then what will happen? Manually you have to go and they shut no shut. So what happened? Everybody when they came after lunch, they started shouting, "Arey, net is not working. We are not getting connectivity." See, they are all accountant or clerical job. So they don't know what is going on. They are not able to access. So somebody came in the lunch time and he removed all the cables. He connected his own laptop. He was unauthorized, so he shut down all the ports and went away. God knows who came and who did this. So all were shouting. There were 10 employees who lost the connectivity. So there is a chance that somebody might do this purposely also. So it is better you do what? Restrict. In restrict, what happens? He will not be able to access internet or some other server, and at the same time the port will also not go down, and there will be a log SNMP trap generated, and finally everything will be in control. At least he will be saved. At least the genuine authorized users will be saved. Got it? Protect is also same, but only difference between restrict and protect is, in protect what happens? There is no log message and the port is still up. In restrict also the port is still up. In protect also the port is still up. In shutdown, port is down. So see, shutdown is a good one, but shutdown can be a kind of an attack. I told you this actually happened in my company. 10 people lost the connectivity because some unauthorized guy came there in the lunch time. He connected his own laptop, might have connected his laptop. That time there were no cameras and all. So some guy must have come with his laptop connected, wanted to be in the LAN access, and he shut down everything, error disable, because port security was configured. So he shut down all the ports and went away. Error disable, shut down. So afterwards we came to know, and manually, see, normally nobody keeps it auto recovery because they wanted to see what was the problem. So nobody keeps auto recovery, because if auto recovery was that, they would have come back again. But according to IT, according to the security standard, people don't do auto recovery because they want to see why the port went into error disable. No, like if you are not feeling well, and if you are, if you are having this problem continuously, and if you are getting a hint, you go to doctor and test it. No, hints are important, no? So hint is there that there somebody came and did this mischief, and they all the ports went into error disable. So next time people can keep a watch. So restrict is good because it will at least it will not shut down the port, and at least it will send us SNMP log also that somebody tried to do mischief with this port and somebody is trying to connect. Got it? And protect is again safe, same, but only difference between restrict and protect is protect don't do SNMP messages. Okay, if you want I can show you this practical next time. Okay, I hope this lecture was informative to you guys. I hope you enjoyed this lecture. Okay, if you have any queries you can ask me afterwards also in the next lecture before starting the lecture. Okay, thank you very much for listening this.